Okay, this is lesson 6-1 or point 1, properties of exponents. This lesson starts out pretty simple and then kind of builds and gets a little more complex. For the most part, people tend to like this lesson. So the first thing we start out with are 0 and negative exponents. Okay, so these first two problems, we have 6.7 to the 0 power, and on B, I have negative 2 raised to the negative 4th power. Okay, so anything raised to the 0 power, as long as this number is not 0, so that's your base number. Okay, this 6.7, that's your base number. I always think of it as the big number is the base, the little one is the exponent. Okay, so as long as this base number is not 0, anything raised to the 0 power will always just equal 1. Whoops, because it means there's 0 6.7s, so that equals 1. If it was 0 to the 0 power, that's the only time it would equal 0. Okay, so now B, we have negative 2 raised to the negative 4th power. So we can't solve for negative exponents, so what we have to use is our reciprocal. So that means in order for me to solve this, I would have to say 1 over, it's still a negative 2, you don't ever mess with the base number. But now that I put it under 1, the reciprocal, that negative 4 now becomes positive 4. Continue that. So 1 over negative 2 to the 4th power. Then I could solve it. So that's negative 2 to the 4th power. If you multiplied that, that would be 16. So that final answer would be 1 over 16. Okay, we're going to look at using those same rules. Okay, we're going to simplify an expression. So this says simplify the expression. I have 4x to the 0. Hold on, let me erase that. Okay. 4x to the 0 power over y to the negative 3rd power. And it's over, but remember that line does mean divide. Okay, so we have a lot of stuff happening here. So piece it together. Being that the 4 and the x are not in parentheses, that 0 exponent just goes with the x. If the 4 and the x were in parentheses, the 0 would go to both of them. Okay, but because it's not, it only goes to the x. So I'm going to look at that first. X to the 0 power, anything to the 0 power we know equals 1. 4 times 1 is 4, so far all I've done is solve the top. I have 4 over y to the negative 3rd power. Okay, well, I can't do y to the negative 3rd power until I get rid of that negative exponent. So so for this, we have to do 1 over that. But I already have 4 on top of it. So it's 4 over 1 over y to the 3rd power. It's now positive. I know you're probably thinking that looks crazy, because it is. We can't have division and division in the same problem. You can't have a fraction over a fraction. So what it does is it takes this 1 over y to the 3rd and flips it. So that comes to the top now. So I have 4 times y to the 3rd power all over 1, which means it's a whole number. We don't actually have to write over 1. Y to the 3rd power I can now solve, but I don't know what y is, so you can't actually solve it. So all of that, and it just equals 4y to the 3rd power. Okay, when they worked it out, they went ahead and got rid of this first. So basically, if you have a number with a negative exponent on bottom, it's going to flip to the top so that your exponent becomes positive. Just like if you have a fraction and it's a negative exponent on top, it's going to flip to the bottom to make it positive. So they went ahead and moved that first and said, okay, so we have 4 times x to the 0 power times y to the 3rd power. Then they solved, okay, x to the 0 power is 1, 4 times 1 is 4. We're left with 4 times y to the 3rd power. That's why it's simplifying, because that's as far as you can go. We don't know what y is, so we can't go any further than that. Okay, let's see. I want y'all to try 1, 2, and 3. We won't worry about number 4 for right now. We'll look at some more here in a second. So try 1, 2, and 3. Go ahead and solve them completely, and then I will go over it with you. Okay, on these first 3, we're solving for these. So number 1, I have negative 9 to the 0 power. So anything to the 0 power just equals 1 because it means there are 0 of the negative 9s. Okay, on number 2, I have 3 to the negative third power, so first you have to rewrite it. Anytime you have a negative exponent, it's 1 over that to a positive exponent. Now we can solve that. 3 to the third power, 3 times 3 is 9, times 3 more is 27. So the answer on that one is 1 over 27. Then on number 3, I'm first going to do the top piece. I have negative 5 to the 0 power. Okay, so that would mean 1. Then we talked about anytime you have something to a negative exponent, it's 1 over that. So technically this would look like 1 over 2 to the second power. But we can't have that. Anytime we have that, this flips up. So basically, if you have a negative exponent on bottom, it moves to the top and becomes a positive exponent. So on top, I really have 1 times 2 to the second power, which we know 1 times anything is that number. So 2 to the second power, 2 times 2 is 4. All of that, and our answer is 4. So still looking at exponents, this next part, we're just going to kind of talk about this, but it says to multiply powers with the same base, add their exponents. Okay, what that means, this would be the problem right here. 4 to the 6th power times 4 to the 3rd power. Since they have the same base of 4, and it's being multiplied, by definition, that's what this is a definition, you can add the exponents. So 4 to the 6th power times 4 to the 3rd power, we can rewrite that as 4 to the 6 plus 3 power. And then you can actually do that. 6 plus 3 is 9, so that would be 4 to the 9th power. And then if they told you to actually solve it, then you could work that out. But 4 to the 9th power. Okay, so then that was the product because it was multiplying. Now let's look at one of quotients with powers. So it says to divide powers with the same base, subtract their exponents. So for example, we have 4 to the 6th power, they use the same numbers, over 4 to the 3rd power. That means divided by. Since their bases are the same, it's both a 4, I can subtract my exponent. So I have 4 to the 6 minus 3 power. 6 minus 3 is 3. So that would be 4 to the 3rd power. So basically, so far, as long as they have the same base, that same big number, if you're multiplying, you add your exponents. If you're dividing, you subtract your exponents. You might want to write that down somewhere. So if you're multiplying, you add your exponents. If you're dividing, you subtract your exponents. Okay, and then the third one is power of a power. That sounds confusing, but it says to find a power of a power, you multiply the exponents. So for example, I have 4 to the 6th power, in parentheses, all raised to the 3rd power. So anytime you have an exponent raised to another exponent, you're going to multiply those two exponents. 6 times 3 to get 4 to the 18th power. So I'm trying to think to put it in words for you to write and know what you meant. An exponent raised to another exponent, you multiply the exponents. Okay, you can pause and back that up if you need to finish getting that down. Example 3. Using those properties that we just talked about to simplify expressions. And it says write your answer using only positive exponents. So we're also going to have to kind of use those examples 1 and 2. So on A, I have 3 to the 2nd power times 3 to the 6th power. They have the same base of 3 and it's being multiplied, so I add my exponents. 2 plus 6 is 8, so that is 3 to the 8th power. And then went ahead and solved it too. 3 to the 8th power is 6,561. Okay, problem B. I have negative 4 to the 2nd power over negative 4 to the 7th power. Since they are both a negative 4, it's dividing. We would subtract our exponents. It's always the top one minus the bottom one. So 2 minus 7 is negative 5. So from here, we're not done because it said write it using only positive exponents. So since that is a negative 5, I would put 1 over that. So 1 over negative 4 to the positive 5th power. Just because I put it on bottom, that does not change your base number at all. It only changes the exponent. So then, if you actually were to solve that, negative 4 to the 5th power, we get negative 1 over 1,024. Okay, so both of these would be your answer on this, because I want to see it like this, but then you can also solve it too. Okay, example C. Z to the fourth power, all raised to the negative third power. So since we have a power raised to another power, we multiply. 4 times negative 3 is negative 12, so I have z to the negative 12th power. And we can't have that. We have to have a positive exponent. So negative 12th power, since it's just a number, that's pretty easy. You just put 1 over that and make it positive. 1 over z to the 12th power. Now, we can't go any further because we have no clue what z is. So that's as far as we can go on that one. So, let's see. I'm not going to make y'all try all of these. Let's do... okay, I want you to try number 5, 7, and 9. Okay, so pause the video and I will go over that with you. Okay, on these, we are simplifying these expressions. This has the same base, and they're being multiplied, so 10 to the fourth power times 10 to the negative sixth power. Since they both have a base of 10 and it's being multiplied, you add your exponents. 4 plus negative 6 is negative 2. So 10 to the negative second power, so that would be 1 over 10 to the second power. And I can't remember if it said to solve all the way or just leave with a positive exponent, so I'll go ahead and do both. So I can't remember if that's your answer or if you go ahead and solve. 10 to the second power is 10 times 10, so 1 over 100. Okay, on number 7, we have negative 5 to the 8th power divided by negative 5 to the 4th power. Since the bases are the same, they're both negative 5, you subtract your exponent. So I have negative 5, 8 minus 4. 8 minus 4 is 4, so I have negative 5 to the 4th power. Then we can solve that. Negative 5 times negative 5 is positive 25. Actually, if I write it out, remember we've talked about, or if I can't remember if we have, so I'll say it again. If you have a positive exponent to a negative number, it's going to give you a positive answer because there's enough to cancel out. If it's odd, your final answer is negative. I know a negative times a negative is positive. Same thing. So then I have 25 times 25, and I can't remember what that is. It is 625. Okay, last one, number 9. I have an exponent being raised to another exponent. So we multiply our exponents. Negative 2 times negative 1. Negative 2 times negative 1 is 2. 6 to the second power means 6 times 6. So it is just 36. Okay, so the next thing we have is power of a product and power of a quotient. So that's not quotient of a power. It's different, okay? So, for example, they use numbers just to make it easy, but some of these might be letters in your actual problems. So it says to find a power of a product, find the power of each factor, and then multiply. So what that means, for example, they're saying if you have this as your problem, 3 times 2 to the 5th power. I know normally we would multiply 3 times 2 and then raise it to the 5th power, but they're just showing you an example with numbers. When this might be a 3 times, that could be an x. Then to the 5th power. We don't know. So what we would do, since they're being multiplied and it's all raised to the 5th power, I could split them apart. I could say, okay, that means 3 to the 5th power times 2 to the 5th power. Okay, and then you could maybe solve those individually because some of them might be where you could solve this half, but you can't solve this half. So it helps us to simplify our problem more. Okay, so then the same thing with power of a quotient. If I have some number over maybe s or f, it doesn't matter, but then all raised to the 5th power. That goes to the top and the bottom. You could split it up and say, okay, that means 3 to the 5th power over 2 to the 5th power. And then you could work it out from there. Okay, so based on that, let's look at a couple of examples I think will help you make a little bit more sense because we're going to have letters in there. Okay, so we've got 4 examples we're going to look at. So A, we're simplifying each expression and write your answer using only positive exponents. Okay, we're just simplifying because that means we're not going to be able to get one final answer. It's going to have several things in it. So A, says negative 1.5y all raised to the second power. So that means negative 1.5 times y, so I could split those apart. I could say, well, that's the same thing as saying negative 1.5 to the second power times y to the second power, which is what they show here. They've split it apart. Then I can't solve y to the second power, but I can solve this. Negative 1.5 to the second power is positive 2.25. And then I know it's times y squared, so I put times y squared. That is as far as we can go. 2.25 y squared would be your answer. Okay, so then the next one, B. I have a over negative 10 all raised to the third power. So I can split that up. That means a to the third power on top over negative 10 to the third power on bottom. I can't solve anymore for a to the third power because we don't know what a is, but I can do negative 10 to the third power. That is negative 1,000. So that simplifies down to negative a to the third power over 1,000. Okay, the next one, C. I have 3d over 2 all raised to the fourth power. Okay, so that means the whole top raised to the fourth power, 3d to the fourth power over 2 to the fourth power. Okay, well, I have 3 times d all being raised to the fourth power. So that really means the same thing as 3 to the fourth power times d to the fourth power, which is what we have here, still over 2 to the fourth power. I'm going to slide it down. Okay, so when we get to this point, I can do 3 to the fourth power. It's 81. I still have times d to the fourth power over 2 to the fourth power, which is 16. Okay, this is our final answer, but you do need to make sure that you can't take anything out of these two numbers. Okay, they don't have anything in common on this one, so we just leave it like that. But every once in a while, that part could be simplified. So our final answer is 81 d to the fourth power over 16. So this problem combined pieces from A and B together. You can have multiple pieces in there. Okay, so then looking at problem D. 2x over 3 all raised to the negative fifth power. Okay, well that means everything on top to the negative fifth power over everything on bottom to the negative fifth power. Now, we've talked about when it's a negative exponent, you have to flip it or put it under 1. But since this top one is negative and the bottom one, if you did that to both of them, basically this whole fraction just flips and they become positive exponents. So this 3 to the negative fifth on bottom now comes to the top as 3 to the positive fifth power. And this 2x to the negative fifth power on top now flips to the bottom, 2x to the positive fifth power now. So from here, I have 2 times x all raised to the fifth power, so I break that down even more. That means 2 to the fifth power times x to the fifth power. Then from here, we can solve. 3 to the fifth power is 243 over 2 to the fifth power is 32. We don't know x, so we keep it x to the fifth power. 243 over 32 x to the fifth power. Okay, so over here they kind of explain that same problem again. They say because the exponent is negative, you could also find the reciprocal first, then simplify. So that means right here where we took that negative 5 and went ahead and split up the top to negative 5 and the bottom to negative 5, we could have from this point rewritten it as 3 over 2x all raised to the positive fifth power and then broken it down. Would have gotten us the same answer, okay? Because just like if it was 2x to the negative fifth, we know to rewrite that, that would become 1 over 2x to the positive fifth power. Okay, well then we have to do the same thing with that bottom number, 3. So when we end up flipping them, they just split places. The one on top goes to the bottom, the one on bottom goes to the top. So that final answer was 243 over 32 x to the fifth power. Okay, let me erase this so you can see the problems. right, I want you to try 11, 13, and we'll go ahead and do 14 too. So you just don't have to do number 12. So 11, 13, and 14. Pause the video, try those, and then I will go over it with you. I know these are complicated, so take your time, try your best, and then I'll go over it with you. Okay, so these last three problems are a little trickier, but on these we are just trying to simplify it using positive exponents. So on number 11, I have 10y in parentheses to the negative third power. So that means everything in here is raised to the negative third power. I can't solve that until that's positive. So that would be 1 over 10y to the third power. Okay, and that means that goes to everything, so it's kind of the same thing. You don't have to write this step as 10 to the third power times y to the third power. So I can solve that. 10 to the third power is 1,000, so 1 over 1,000 y to the third power, because I don't know what y is, so that is as far as we can go. Okay, on number 13, it gets a little bit trickier. It's a positive exponent already, okay? But that's the same thing as if I rewrote it like this. 1 to the 5th power on top, everything on bottom to the 5th power as well. Okay, well I know 1 to the 5th power is 1, because 1 times anything is just 1. On bottom, I know it goes to each individual piece. Excuse me, sorry about that. So, I have 1 over 2 to the 5th power. Now this, that's k, actually, let me just do it one step at a time. I don't want to get ahead of myself and confuse y'all. So k to the 2nd power to the 5th power. I'm kind of distributing it in. I can do this, 2 to the 5th power. I can't even remember what that is, so I'm going to plug it in the calculator. That is 32. So 1 over 32, okay, the 2nd power to the 5th power. So whenever I have this, an exponent raised to an exponent, you multiply them. 5 times 2 is 10. So our final answer is 1 over 32 k to the 10th power. And that is as far as we can go. Okay, now our last one, problem number 14. And again, I know these are tricky, so if you're struggling on these, it's cool. Don't stress about it. Okay, on number 14, I have 6c over 7 all raised to the negative 2nd power. First thing we need to do is make that negative 2 positive so that we can solve. That means we would put 1 over all of this. But remember, anytime you have a fraction, over a fraction, over a fraction, it just flips it. So basically, anytime we have that raised to a negative exponent, since the whole thing is, I can just flip it, and now it's positive. Okay, that's doing this, putting 1 over it, but a fraction over a fraction flips it. So now, if I split it up even more, I'm going to put this second exponent with the top and with the bottom. 7 times 7 is 49. I can go ahead and split that apart because it goes with both things. 6 to the 2nd power is 36. And then next, what we would do is if I could simplify anything out of those numbers, we would. I don't think anything comes out of them. I'm trying to think. 39, 42, 45, 48. No, nothing comes out of both of those. So that is your final answer.